Hey, welcome back to my channel. If you didn't watch the last video, I would advise you go back to it and go through it where we were able to solve a beam with a settlement using three moment equations. But this time around, we are going to be solving a different question on beam, still three moment equation, but this time around not carrying a settlement. After this, we'll be moving to slope deflections and then to moment distributions. So but then at this beam, if you can look closely, we have how many supports? Support A, support B, support C, support D, and support E. And at support A to B to C, we have a uniformly distributed load of 15 kilonewton, and at C to D, we have a point load of 20 kilonewton. At D to E, we have two loads there acting on 2 meter spans, which is of 10 kilonewton. And the first thing we are going to be doing here, like we did the previous time, was to generate our three moment equations. And generating our three moment equations, I'm going to be picking it three supports by three support. I support A, B, C, B, C, D, and C, D, E. I'm going to pick A, B, C, B, C, D, and C, D, E. I'm picking support A, B, C. I'm going to be taking my considerations at support B. At support B, at this particular loading, moment at A will be equal to 0 and moment at E will be equal to 0. So my main considerations here is B, C, D. Normally this should have also been equal to 0 because they are roller support. But for the fact that it's inside a beam, that means there should be a moment there that would nevertheless still cancel each other at the end of everything. So I'm going to be finding my moment at B. So I'll generate my equation at support B. Generating my equation at support B, I'll have that moment at A multiplied by the length of A to B, then plus 2 moments at B multiplied by the length of A to B plus the length of B to C. It's very simple to memorize this formula. Moment at A multiplied by the length of A to B, two moments at B multiplied by the length of A to B and B to C. Now I'm here, so moment at C plus moment at C multiplied by the length of B to C, so equal to minus 6 reaction at B left I naught over I minus 6 reaction at B right I naught over I. At this time around, I'm not going to be adding my settlement equation, which is 6 EI settlement value. So but then at my support C, which I'm now considering this, and this, that is B, C, and D. And B is the very first support there. So I'm having my moment at B multiplied by the length of B to C plus 2 moments at C multiplied by the length of B to C plus the length of C to D. Then plus my moment at D multiplied by the length of C to D equal to minus 6 reaction at B minus 6 reaction at C left I naught over I minus 6 reaction at C right I naught over I. Then at support, likewise at support D, my equation is going to be C, D, and E. So my moment at C multiplied by the length of CD plus 2 moments at D multiplied by the length of CD plus length of this E, which should be plus moment at E multiplied by the length of D to E, which is equal to minus 6 reaction at D left I naught over I minus 6 reaction at D right I naught over I. So this is my equations I'm going to be working with. So the next thing I'll be doing here is to load my beam. And when I load my beam, loading this beam, I'm going to, if I load this beam Because it's a UDL, it's going to be deflecting, it's going to be bending in a parabolic form, and from B to C will also bend in a parabolic format, and then there's a point load acting on the center, so it is going to bend towards the center. And at this point I'm having two loads, so it's going to bend this way and also going to bend this way, but because they are carrying the same force, the same 10 kilonewtons, so they will both stop at the same point. And then if I close it, you see that I'm having a shape that looks like a trapezoidal shape, and then this is a triangular shape, this is a parabola shape. So from here I'm going to transpose my loading. If I transpose my loading, it's going to move upwards, and then this moves the same way, and this deflects at the center, and then this moves and they meet each other, where here becomes my A span and then here becomes my B span. So I'm going to be having one reaction at A, two reactions at B, which is reaction at B left and my reaction at B right. Likewise here, I'm going to be having my reaction at C left and my reaction at C right, and my reaction at D left and my reaction at D right, and lastly my reaction at point E. So if I have these, the next thing for me to do is to calculate my maximum bending moment. To calculate my maximum bending moment for the different spans. To calculate my maximum bending moment, I'll have that my moment at A to B would be equal to, because it is a UDL, is going to be WL squared over 8, which should be equal to 15 times 5 squared over 8. Then for moments at BC, I'll have it as the same WL squared over 8, and at this time it's going to be 15 times 4 squared over 8. Then my moment at C to D would be equal to, it is a point load that is acting on the center, so that will be PL over 4, which should be equal to 20 times 6 over 4. Then my moment at D to E, remember this is now a parabolic shape. To calculate the maximum bending moment of a parabolic trapezoidal shape would be equal to PA. That means a trapezoidal shape that is carrying the same loading. So this will be PA, and PA will now be 10 times A being one of the distance, which is 2. So okay, from this we've been able to calculate our maximum bending moment at AB to be 46.9, at BC to be 30 kilonewton, at CD to be 30 kilonewton, and at DE to be 20 kilonewton. So doing this, the next thing we now have to do is to calculate, because we have inertia on our questions, we are going to be calculating our imaginary length, and from there we'll move to calculating our imaginary reaction, so that we can substitute inside our formula and be able to find our moments. To calculate my imaginary length, I'm going to be calculating my imaginary length at A to B. So I'll have my length at A to B prime will be equal to, the formula is length of AB multiplied by I naught over I, where my I naught is the smallest inertia on the question, and then my I is the particular inertia that the span you are considering, the inertia that it is carrying. So the LAB is 5 multiplied by my I naught is I over I. The I here is this list of them here, then the I beneath as a denominator is the inertia of span A to B. So this will be equal to, I can cancel out I, so I'm still having my 5 meters. So moving to the next one, I have that my LBC prime would be equal to LBC multiplied by I naught over I. So this will be equal to, my LBC is 4, so this is 4 times my lowest inertia is I, and that of the BC is still I. So I'm having this still 4 meters. Then moving to CD. LCD would be equal to LCD prime will be equal to LCD multiplied by I naught over I, and this is equal to, and this will turn to, my LCD is 6, so 6 times my lowest inertia is I, and that of the inertia of CD is 3I. So 6 divided by 3, I will cancel I, so 6 divided by 3 we have it as 2 meters. Then the inertia for LDE would be equal to, LDE prime will be equal to LDE multiplied by I naught over I, and LDE is 6, so 6 multiplied by the I over 2I. So this will be equal to, I will cancel I, so I'm having this as 3 meters. So I've been able to calculate my imaginary reactions. Then the next thing we are moving into is to calculate our imaginary reactions. And calculating my imaginary reactions, I will know that my reaction at A, the reaction at A will be equal to reaction at B left. Reaction at B right will also be equal to reaction at C left, and reaction at C right will be equal to reaction at D left. And then I'll have to calculate my reaction at D right as well. So doing that, I will now know that, remember from the last time we calculated our reaction, we calculated our imaginary reactions as area times the centroid divided by the length. So the same case here, we have our area times the centroid divided by the length, which the area of a parabolic shape, the parabolic shape from A to B, is 2 over 3 times the breadth times height multiplied by L over 2. And substituting inside this formula, I'm going to be having that this is 2 over 3 multiplied by the breadth from our question here is 5 meters. The breadth is 5 times, and the height that we calculated, that is the height of A to B, was 46. That means we can put here that this is 46.9, and this is 30 kilonewton, this is 30 kilonewton, and this is 20 kilonewton meter. Then my height is 46.9 multiplied by the length is still 5, that is 5 divided by 2, all divided by 5. And if you calculate that, we'll have a value. So let me proceed ahead to the next one. We have that reaction at B right will be equal to reaction at C left. So this is equal to area times centroid over length, which is still equal to 2 over 3 multiplied by the breadth times the height, all multiplied by L over 2 divided by the length of B to C. And this will be equal to 2 over 3 in brackets. The length, the breadth here is 4. So this is 4 times, and the height from what we calculated is 30. 4 times 30 multiplied by 4 divided by 2 over the length of B to C is still 4. So if you press that on your calculator, you will have a value. And then let me proceed to the reaction at C